showing you that picture up there. This is from your city book. And the city book on space is one of the references for you to read today. I hope you do read the references. The way that I pick the references is so that they complement what I show you in class. Since some of you weren't here yesterday, just to go over, these are my note cards. Instead of standing up here with a stack of notes and reading off them and copying on the board, I use prior view graphs from classes that I've liked, or that I've liked primarily. That becomes my note card. So this is what you need to focus on, is what's up here. I tried to make a video summary of it, put it online. I'm still learning how to do that, to keep it of a reasonable size, and under 15 minutes if I can. So, all these things that are shown on the view graph from the computer are available to you online at the PolyLearn site. They're all there, so you can go and look at it. And there's more than I can cover there. So you'll find the same topic covered different years with different questions were asked. You'll see mistakes on the view graphs that have been corrected, hopefully. There's no intentional mistakes there, but you'll see things that were corrected. And then the reading material from both my book, City's book, and Nelson's book on a given topic is intended to focus that idea, focus it together. Okay. So I hope that works for you. And today we're going to go through some important reference frames. We can see a lot of them up here on the picture over here of the city book. We see the one that's at the sun. That would be like our capital inertial frame. And then we have one at the earth, which is our little eye. And then we have a lot of other ones that I'm going to go through right now that you need to know. Then what we're going to do at the end of the hour is go through the reference frame, one of the ECEF reference frame, and show you how to derive the direction cosine matrix that goes with it. So, here's our little Earth. And since we're airplane people, right? We're airplane people. So we don't care about what our distance is from the sun. We assume that the sun is going to be there, but we do care where we are relative to the Earth. So relative to the Earth, we always use ECEF, where ECEF means Earth-centered, Earth-fixed. And what else uses your ECEF coordinates? GPS. Right, GPS uses it. So we care where we are and how fast we're going relative to the Earth. So I might have a vector, and let me just pick a vector. Let's pick an arbitrary vector. And I'm going to call it vector VK. We'll use this later. We'll just say vector VK, and we'll define that to be the rate of change as seen by someone on the Earth of a position vector. And a position vector, we'll call that rho k. So we'll just start with that, this vector, and then play with it today. We'll play with VK more later on in the week. So I'm interested in my velocity relative to the Earth, but I need to be able to express it in all these reference frames. And why do I need to express it anywhere at all relative to the inertial frame? Does anybody remember? This should be a small I anyway. Does anybody remember why I need the inertial frame from yesterday? Because why? It doesn't rotate. It's a Galilean frame, and that's the only place where Newton's laws hold. So we're always going to start with inertial reference frame so we can get our equation started. And then we're going to go through different equation sets, and each one of these is going to have a name for us to get to where we want to be, which is called the vehicle carried vertical frame. Vehicle carried vertical frame, and that takes us into the body frame. So we'll introduce all these frames today, and you'll see them again next week in some depth and detail. And when you read in the City and you read about these topics in Nelson, they'll be close. So let's go from the inertial reference frame to the ECEF. They both have the same origin, yes? All right. And then the ECEF rotates once a day, every day. What meridian defines the ECEF? What meridian? No, the meridian is this way. What meridian defines the ECEF? The prime meridian, which goes through Greenwich. And why does it go through Greenwich? Because the English rule the world. No, it goes through Greenwich. There's lots of reasons why that's true. But that's good, and we have to live with that. So the prime meridian goes through Greenwich. So our first rotation is going to take us through the IJ equatorial plane. The I and J vectors are going to rotate until they're on the prime meridian plane at the equator. So I, J, K. I, J, K at the equator is our capital E system. Okay? That's this system. We have to figure out how to get from ECEF to E. Because we went from the prime meridian to E, which is going to be somewhere off the prime meridian. We're not going to be at the prime meridian. We might be somewhere else at some longitude. So from the ECEF, the prime meridian plane is going to become a plane that we're located on, and that's called the E plane. Then, so we move the E from the prime meridian. So how do I get to the latitude? Well, now I have to rotate. I have to rotate this guy. I'm going to rotate it, and then I'm going to rotate about the J vector. Does it bother you that I'm moving the origin around? Don't worry about moving the origin around. It's the relative orientation of the frames that's important, the relative orientation. So I can move the origin. So I'm going to rotate about the J vector. When I do, I'm going to end up at San Luis Obispo, and that's going to give you my little E frame. And that's where I want to navigate from. I want to navigate my relative velocity relative to a fixed frame at San Luis Obispo. Then I might want to go flying. If I go flying, I'll have an aircraft, and I'll be flying around San Luis Obispo, and I'll be carrying a northeast down frame with me up here. That's called a vehicle carried vertical frame. And then my body axis, as you saw from the acrobatic flight from Patty Northrop, my body axis might be rotating. So if I'm looking out the window of the airplane, I might be having all kinds of different attitudes relative to northeast down. That's the body frame. Knowing all those gives me what's called situational awareness. So a big factor tomorrow and the next day is going to be situational awareness. You'll see this come up again and again and again. This is crucial. This is crucial. And as engineers, it is your job to provide the instrumentation and the techniques and the procedures that give situational awareness to the pilot. You should provide the instrumentation so that he or she has situational awareness no matter what their attitude is in the aircraft or where they're at. It's a lot. Got it? Okay. So if I'm going to derive the ECEF, two ECEFs from the I, and follow this three-step process, I'm going to first pick a common vector. What's the common vector between the ECEF and the little I systems? The K vector. So then I'm going to draw a diagram looking up or down the K vector. Okay. So I'm going to look down the K vector, which I think is what I have, over here. Let's see. So we'll draw it like this. We're looking down the North Pole. There's a North Pole coming at us. We're looking down the K vector. So I would look like that, and JI would look like that. Is that correct? So I have I, J, and K will be coming out at you. Yes? Is that correct? Okay. Then I know that through angle omega delta t, through this angle, I'm going to have the J vector in ECEF because I rotated about. So there's going to be this angle here, and then this angle here will be J, ECEF. Now this is the hard part. If you can do the first two, and again this angle over here is going to be omega delta t.
Is the one on the right supposed to be in the I?
Yes. Thank you. That should be the I. Now once you've got the two steps done, I'm looking down on the Earth. I see I, J, K. Then between that and the prime meridian, that's the angle. Okay, now I project the old onto the new. So the new I vector will be going across this way. So the new I vector is going to be ECEF because that's where I'm going to. I project the old I vector onto it, and I get the cosine of omega delta t. In other words, what does project mean? Project means drop a perpendicular, yes? drop a perpendicular. So what is that distance there? Well, both of these have unit 1, so it's 1 times the cosine of the angle. So it's just the cosine of the angle, cosine delta t. So that's the I projected onto the nu. What is the j vector projected onto the nu? Well, if I were to project the j vector onto the nu, I want this distance here, and that distance there is going to be, since this angle omega t and that angle omega t are the same, it's going to be 1 times the sine of omega t. And it's projecting on the plus side, so it's going to be plus sine of omega delta t. Like so. I use C and S for cosine and sine. And finally, the k vector is perpendicular coming out like this. And so if I project the k vector onto the new ICEF, I'm going to get 0. Done. Take the next one. I had the new IECEF. Now we have the new j. So we'll project the old vectors onto the new for the second row. I project the old I onto the new j. Whoa. Look what's going to happen here. When I project it, I'm going to go on the back side. You see that? I'm going to go on the back side of the JECEF vector. And it's going to be by the sine again. This angle and this angle are the same. So it's going to be minus the sine of omega delta t. Minus the sine because I projected on the back side onto the new j vector. The old j vector and the new j vector, again, omega delta t is going to be just the cosine of omega delta t. And the k vector, once again, is perpendicular. 0. Finally, project the old onto the new k vector. The new k vector is coming out like this. I project the old I vector onto it, and the old j vector are going to be 0. So this is going to be 0, 0. And since the k vector is aligned between the two systems, I'm going to have 1. And there you have it. That's how you do it. That's the 3-step process. Now sometimes the k vectors will be opposite each other, the old frame and the new frame. Sometimes you'll have to think it through with a diagram to play with it. This is just the first cut as to how you do it. What if you needed to go into I from ECEF knowing this? What would you do? You just transpose this, yeah? So these signs would switch places, and you'd have the same matrix if you wanted to go one way or the other.